Here's a little more Unit 3 review for you. I would suggest that you get paper, pencil, calculator, periodic table, have all the formulas that you think you need ready, and then actually work these problems and use this video to check your work. So here's your first problem. How would you attack this problem? Well, if you're thinking you need an equation, you are exactly right, because this is telling us that oxygen gas is reacting with fluorine to make oxygen difluoride. And I'm trying to figure out how many liters of oxygen gas I need. And that STP is really jumping out at me. So when I see STP and I'm working with gases, I'm thinking, okay, standard temperature and pressure, 0 degrees Celsius, 1 atmosphere of pressure. That at these conditions, that 1 mole of a gas takes up a volume of 22.4 liters. And so that's what I'm being asked to find. So what do I need to do with this equation? Hopefully you're thinking balance it, and you are exactly right. Now go ahead and work this problem. So hopefully you worked that problem, and you started with what you were given, which of course is 2.55 moles of OF2. And we're assuming here that we have excess fluorine gas, since the problem doesn't mention it. And so we are going to first use our mole ratio from our balanced equation to convert those moles of OF2 to moles of oxygen. Notice that my moles of OF2 cancel out here or diagonally drop. And I get 1.275 moles of oxygen. Now that I know moles of oxygen, convert that to liters of oxygen, and we get 28.56. And of course, I'm going to now look back at my problem, see, oh, I've only got 3 significant figures, so let me round that to 3 significant figures. Here's your next practice, because practice makes perfect, but not only do you have to practice, but you have to practice perfectly. All right, so go ahead and attack this problem, pause the video, and then come back and see how you did. All right, so obviously this is a mass volume percent. So the first thing I always like to do is start with my formula when I'm working with these and then go from there. And so this one is actually asking me to calculate the percent. I have the mass and the volume of the solution, so I'm good to go. The only thing I need to do is I need to remember that for the volume of these solutions, my volume has to be in milliliters. Mass is in grams, volume is in milliliters, and I remember that because they are kind of similar. 1 milliliter of water does weigh 1 gram. And so it's simply a matter of substituting in my mass and my volume in milliliters, divide those, multiply by 100, and get 6%. And of course, I've given those 2 decimal places so that I have 3 significant figures. Here's another one. All right, how did you solve this one? Once again, we've got a mass volume percent. Remember that volume has to be in milliliters. But for this one, I don't have the mass of my HCl, but I do have moles. And so, of course, you converted those moles to grams for HCl and figured out there's 18.98 grams of HCl. Then substitute both values given in the problem into the equation. Divide 18.98 by 450, multiply by 100, and you've got a 4.2% solution. Here's your next one. So obviously in this one, I was looking for grams. I have my percent solution, and so again, I always like to start with that equation. You can rearrange the equation, but to me, these equations are a little cumbersome, so I always like to substitute in the values given in the problem next, because I know it's a 24% solution, and I know the mass of my solution is 250 grams. Then I work on solving for the mass of the solute. You can make that X. The first thing I always do is divide by 100. And now I'm going to multiply each side by 250 to get the mass of my solute. which is 60 grams. Now there should be a decimal point behind that 60 to make it have two significant figures. Here's your next solution problem. Go ahead and attack this one and then come on back. Obviously, this one is asking for molarity, and so right away I'm going to be thinking, okay, molarity is my number of moles per liter of solution, and that's why I always use a big V there for volume. But I don't have number of moles, but I do have mass, and I know that if I use my molar mass, I can always convert grams to moles. So I'll take those grams, divide by my molar mass, and find that I have 0.5 moles of H2SO4, sulfuric acid. Divide by my volume, convert it into liters, and my concentration is a 2 molar solution. And we've got two significant figures there in our answer because that's the least number in our problem. Here we go, another one. Pause the video and then come on back and see how you did. All right, so for this one, obviously it's a molarity problem again. I see that I've got my volume, 125 milliliters, and my molarity, and I'm looking for grams. So again, I'm thinking, okay, I've got to figure out moles because from moles I can always get grams. And so I'm going to rearrange this equation because this one is a kind of simple one. And then I'm simply going to substitute in the molarity and the volume. Volume, of course, in liters. And my number of moles is calculated. Now all I got to do is multiply that by the molar mass of glucose, 180 grams per mole, and I get my number of grams. Go back and round that to two significant figures. Here's another one. Take a second, pause the video, and then come on back. Obviously, this problem is asking for molarity. So right away, I'm already thinking my molarity is my number of moles divided by my volume in liters, but I don't have number of moles. I have volume, but I can always take my grams and convert to moles using my molar mass. And so I calculate my moles of MgCl2, divide by my volume in liters, and there's my molarity, rounded to two significant figures. Here's another one. So this one looks a little different because I have a chemical equation. So this is going to be a solution stoichiometry problem. So pause the video and then come on back and let's see how you did. All right, so as I'm attacking this problem, right away, I am looking at what I have to work with. Well, I know how much BaCl2. I know my concentration for BaCl2. And I'm looking for my volume. I know also that I have two values for my NaCl. This is what I'm trying to make. And I have my molarity and my volume for my NaCl. So your first thought might be to use the dilution formula. But in this case, you can't do that because when you're looking at your equation, notice that 2 moles of NaCl are equal to 1 mole of BaCl2. And so that's how you know you've got to use stoichiometry. And so the first thing I'm going to do is figure out my moles using my molarity equation because I know that for sodium chloride, I've got my volume and my molarity, so I'm going to figure out my number of moles by multiplying those two together. Now this works because big M molarity is actually moles divided by liters. And when I do that, notice that my liters here are going to cancel out. And that leaves me with moles. So my number of moles in that volume of solution is 0.0052. Now I know from looking at my equation that 1 mole of BaCl2 equals 2 moles of sodium chloride. So I'm going to use that mole ratio to figure my moles of BaCl2. Then all I need to do is look at my molarity equation again because my number of moles divided by molarity is the volume. So I'm going to take the number of moles I calculated divided by the molarity of BaCl2 to get the volume that I need in liters. but I'm not going to be able to measure that in liters. So I would convert that back to milliliters. So I would simply move that decimal over 3 places. So it'd be 10.4 milliliters. And I can keep it with 3 significant figures based on the measurements in my problem. Here is one last one for you. So go ahead and work this one and then come on back and we'll see how you did. All right, so I'm looking for grams of KCl. I have my volume and I have my molarity. So right away, I'm going to my molarity equation. And I'm going to try to calculate my number of moles because I know from my number of moles, I can always get grams by multiplying by molar mass. So my molarity times my volume. I get my number of moles of KCl multiplied by my molar mass. And I get my grams of KCl and round that to 3 significant figures. I hope these have helped you as you're preparing for your Unit 3 exam.